Hello, my viewers. Once again, you're most welcome to this YouTube channel. My name is Bwami Elisa, your math guy. So today we are going to look at inequalities, and we are going to use 3 questions which will work as our demonstrative examples. And this is our first question, and the complexity will vary. So let us first look at this question number 1, as simple as it is. And let us look at what we need to handle such a question. So our question says that solve the following inequalities. And part A says 5x plus 4 is less than 19. So our solution for part A, we shall say that 5x plus 4 is less than 19, and we shall make sure that this number, this 4, is taken to the right. So in our next step, we shall say 5x plus 4 minus 4 is less than 19 minus 4, and this will become a 5x less than now a 15. And after this, we shall divide both sides by this 5 such that our x can stand alone. So I can rewrite this step. So by 5, we remain with our x finally less than a 3. And this is our solution. This is our solution concerning that problem. And for part B, there is something special at this part B. With our 3 minus a 2x being greater than a 12, we shall first make sure that we take our 3 to the right hand side. So we shall end up with a negative 2x greater than a 12 minus a 3, which will now become a negative 2x greater than a 9. And at this very step, dealing with a negative, we have to be very cautious. Dividing from this very step, that divide by a negative 2, divide by a negative 2, is wrong. We should never do that. So what we shall do is that we shall rewrite this, but on acknowledging that we are yet to divide by a negative, we shall make sure that we change the sign at this very step of dividing by a negative. And so this will become, we shall divide both sides by a negative, and at this very step of dividing, it is where the negative should, where the sign should change. The sign should be reversed. So finally we shall get our x less than, you divide here, negative 4.5. And this will be our solution. Ladies and gentlemen, so this is our number 2. This is our number 2, and we are told to solve the following inequalities. This is part A, and we are going to do part A together. You will try out part B yourselves. So part A, we are having x squared minus x minus 2 greater than or equal to 0. So when we look at this, this is a quadratic expression. And we shall ask ourselves, can we factorize this quadratic expression? And if it is possible, we shall do that. So this x squared minus x minus 2, we can write it as, I'm saying that it is equal to, we can write it as x squared. Now we think about 2 numbers. We know all that process. If you don't know about that, you can look at the video having quadratic equation as a title. So we can factorize this. This is minus 2x plus x. We break this into 2 terms. So finally, from this we shall get our x squared. We shall look at this as a pair of those 2 quantities, and we shall pull out an x here, get an x minus 2. We pull out here a 1, we'll get an x minus 2. So finally we get x minus 2 and x plus 1. So we have seen that we can express this quadratic expression in terms of its two factors. So our statement, our problem shifts from this one now to x minus 2 into x plus 1 being greater than or equal to 0. And from this step I will get my critical points. And I get critical points by equating these brackets separately to a 0. So I will say that x minus 2 is equal to a 0. And this gives me my x as a 2. And also this bracket x plus 1 is equal to a 0. This gives me my x as a negative 1. So the critical points are I have a negative 1 and a 2. I write them in ascending order from the smallest to the biggest, in that order. And these critical points are going to be used in terms of regions which these critical points can separate. In a simple way of understanding this, just put these critical points on a number line. And you will see that these critical points separate these numbers into 3 regions. We have this region which is having numbers less than this one, less than negative 1. We have this region between negative 1 and 2, and this region with numbers greater than 2. So after doing this, we are going to use these critical points to draw a table. And this table of ours is going to have regions in which x, remember our variable in study is x. These critical points are of x. So we are going to have a region in which x is less than or equal to a negative 1 because it is considered here. We are going to have another region in which x is in the middle, in other words, x is less than or equal to negative 1 is less than or equal to x, which is less than or equal to a 2. And finally, our x being greater than or equal to a 2. So these are our 3 regions from which we expect to have a solution. And these regions, we are going to test them. In terms of sign change. Concerning these 2 brackets. So I will directly put here x minus 2 and my x plus 1. And I will ask myself, which number can I pick? Which value of x can I pick? And it is indeed less than a negative 1. So I can pick a negative 5. I'm going to consider this value. I can consider another value. Which value is indeed in the middle of negative 1 and a 2? I can use a 0, and here I can use a 5. I can even use a 10, whatever value, as long as it is indeed greater than a 2. So when in this region I consider negative 5, and the negative 5 is placed into this bracket as x, I will get a negative value or a negative quantity. The same region, a negative 5 placed here, I will get a negative quantity. Now I go to a 0. I do the same thing. For a 0 in this bracket, we shall get a negative. The 0 in this bracket, we shall get a positive. Our 5 in this bracket, we shall get a positive. The same 5 in this bracket, we shall get a positive. And now looking at these 2 brackets, they are multiplying themselves. It is a product. So this time with this gives us the x minus 2 and x plus 2. And this time with this, negative times the negative gives us a positive. Negative times a positive gives us a negative. Positive times a positive. And now we shall ask ourselves, in which situation is this product greater than or equal to a 0? It is until when it is positive. It is until when it is positive. So we shall look at these positives and where they came from. These are our solutions. So we shall therefore say that therefore x less than or equal to a negative 1 and x greater than or equal to a 2 are the solutions. So, okay, now this is number theory, and we are given a rational function. And when we look at such, we should never cross multiply, because you may think of looking at this as a fraction, 2 over 1, and you feel like it is right to cross multiply. That is wrong, because I can say we are not sure whether this quantity is a positive or negative, and we know what we should do when we are to multiply or divide by a negative. So since we are not sure, we cannot just cross multiply. Instead we shall bring these two to this side, and it becomes this fraction x minus 4 over x plus 2 minus a 2 greater than a 0, and this is a 2 over 1. So we get the LCM of this, and the LCM is x plus a 2. So this is x minus a 4 minus a 2. LCM divided by 1, what we get times this x plus a 2 is greater than a 0. So after this, we shall simplify our numerator. We shall simplify, and this will give us x minus a 4 minus a 2x minus a 4 all over x plus a 2 is greater than a 0. Finally, this will give us a negative x minus 2x, and a 0. So that's all, without x plus a 2 greater than a 0. So we shall use this and this for us to get the critical points. If you wish, you can divide through by a negative 1 to make this positive, but you will take note of what I said first, that the sign should change at the step of dividing. Otherwise, you can leave it as it is, and we say that critical points, and we say that we are looking for critical points, and it is when the negative x is equal to 0, this makes x a 0, and the x plus a 2 equal to a 0, this makes x a negative 2. So our critical points are the 0 and the negative 2. We write them in ascending order. So from this we shall draw our table with ranges in which x is less than a negative 2. There is a range in which the negative 2 is less than x, less than 0, that range between those two values, and the range in which the x is greater than a 0. It's greater than a 0. So this is our table, and we are going to be looking at the signs of the negative x. I can just write it as it is, and the x plus a 2. And finally, we shall look at the quotient at this very point from which we got our critical points, the negative x all over the x plus a 2. So we shall pick a value of x which is less than a negative 2, and we can say to use a negative 10. A value of x, any value which is between a negative 2 and a 0, we can use a negative 1, and here we can use a 10 because we are sure it is greater than a 0. So negative 10 in here, it makes this positive. It makes that positive. A negative 10 in here, it makes this negative. A negative 1 in here, it makes that positive. Negative 1 in here, still that is a positive. Now we come here. A 10 in here makes that negative, and a 10 in here, it makes that a positive. And finally, this divided by this. Therefore, a positive divided by a negative, we get a negative. Positive divided by positive, we get a positive. Negative divided by a positive, we get a negative. And then we ask ourselves, from this very step from which we got critical points, in which way is this quotient greater than a 0? It is until when this quotient is positive that it will be greater than a 0. So we look at where we are having a positive. In other words, it is in this range that this quotient will be positive. So this makes this range our solution. So negative 2 less than x less than a 0 is the solution.